The topic for my physics activity is Young's double slit experiment. Now, Young's double slit experiment is a very simple yet innovative experiment which demonstrates the phenomenon of constructive and destructive interference. Here, I have a very rough representation of the setup which Young uses for his experiment. Let us go over the instruments he uses. The first instrument he uses is a monochromatic single wavelength laser to produce a concentrated ray of light of pure wavelength to go through these slits. Now, I don't have access to such a laser, so I'm using a placeholder instead. The second part of the experiment is a small surface with two very narrow slits placed quite close to each other through which the laser is made to pass through. Now, this is a very rough representation, so I've tried to create a similar apparatus. However, in an actual experiment, the slits would be quite a lot closer to each other and they would also be much narrower. The third part of the experiment is a black screen which is placed quite a lot farther away from this slit here. This is made to catch the light which falls after going through these slits. Now let us see the experiment itself. The experiment is started by training the laser on the two slits over here. The slits are quite close to each other, so the laser is made to fall on both of them. As soon as the laser goes through the slits, we notice such a pattern forming on the black screen. Now this is a very rough representation of the actual interference pattern that will form. The changes will be that the edges will be quite blurred due to half interference of the light. Now the observations we make are there are alternating bands of bright and dark spots. The second observation we make that the intensity of the bright spots reduces as we go farther and farther away from the center. Now let us see the theoretical part of this experiment. Here are the details of the experiment listed as follows. Here are the apparatus which are used, including the laser, the slits, the black screen, as well as a dark room so that the prominence of the light waves can be seen. Here is a demonstrational diagram of the setup. Here we can see the surface with two small minute slits through which the light rays are made to pass. Here we can see two light rays going from the slits and creating a pattern like this. Now we can see a rough diagram of the interference pattern that will appear on the screen. I have also made the observations right here of the alternating bright and dark spots which will appear on the screen, as well as the lowering intensity of the bright spots as we move further and further away. Now let us see the actual experiment in motion. I do not have access to all these apparatus, so I will use a clip to explain the actual experiment. Here we can see the apparatus used in the experiment. The single monochromatic laser is placed in front of the slits. Here is a picture of the slits which are used of varying distances between the two slits. We will use the leftmost slit as it will give the most accurate observations. Now let us look at the screen. The screen, as you can see, is placed quite far away from the actual setup so that it will give more accurate observations. This is the screen on which the interference pattern will appear. Now let us set the room dark and train the laser on the slit. As we move towards the screen, we can see the interference pattern appearing on the dark screen. The interference pattern consists of alternating bright and dark spots, which is caused due to alternating constructive and destructive interference. Also, we note that as we move further away from the middle of the screen to the edges, the intensity of the bright spots decreases. Now let us come to the theory part of the Let's come back to the explanation of the experiment. Here we see the diagram of the setup which we just saw practically in the video clip before. Now let us come to the explanation of the experiment. We know that Young's double slit experiment demonstrates the phenomenon of constructive and destructive interference. Now let us come to know why Young uses the apparatus that he uses. The single monochromatic laser is used to obtain a light ray of pure wavelength which can then produce a very pronounced interference pattern. The two slits are very narrow and close to each other so that the interference pattern obtained on the screen is very clear so that the observations may be made accurately. The screen is placed very far away from the slits so that the wave nature of the light rays are pronounced. Now here we see the diagrams of the two situations which leads to the alternating light and dark bands which we noticed on the screen. Now, here we see a situation in which the waves from the two slits meet in a crest to trough interaction. This leads to destructive interference of light, which leads to the dark bands which we noticed on the pattern. Here we see another situation in which the two waves meet in a crest to crest or trough to trough interaction. This leads to constructive interference of light, which leads to the bright bands which we saw in the interference pattern. Now let us study the requisites of the destructive interference and constructive interference. Now, if the actual path traveled by the wave between the two slits differs by one wavelength, this leads to a crest-to-crest interaction leading to constructive interference, which is this situation right here. This is caused due to difference of one wavelength, that is lambda, between the two paths. In this situation, the difference between the path traveled by the two waves is half a wavelength. This leads to destructive interference, which leads to a crest-to-trough interaction at the point, leading to destructive interference and causing dark spots. Now let us come to the calculation parts of the experiment. Here we can see a clear diagram to show the distance between the paths. As the distance between the actual slit and the screen is quite a lot larger in comparison to this distance between the two slits, that is d, we may consider the light rays coming from the slits to be parallel. Thus, we can assume these two angles to be the same, and thus from this diagram we can clearly see that the distance between the two is d sine theta. As we can see here, this d sine theta is the difference in the path traveled by the two waves, which is marked by del L. Thus, we can draw that del L is approximately equal to d sine theta. Now, to obtain constructive interference, where this del L must be equal to an integral multiple of the wavelength lambda which is used. Thus, we can see that at the points of constructive interference, we obtain an equation d sine theta equals to m lambda, where m belongs to any integer. Similarly, for destructive interference, the del L must be equal to half of a half integral value of the lambda. Thus, we obtain the equation d sine theta equals to m plus half lambda, where m belongs to integers. This equation holds true in cases of destructive interference, which is the dark spots. Thus, we can see overall that Young's double slit experiment is a very simple yet innovative experiment which clearly, flawlessly displays the properties of constructive and destructive interference. This experiment played a very vital role in proving the actual wave nature of light. Thus, my experiment ends. Thank you.